The mean proportion is the square root of the product of two numbers, the length and the side of a rectangle, in this case, when expressed as the means of a proportion. The mean proportion allows us to create a square from a rectangle with equal area. Shown here is a rectangle, which can be any length, any side length. For the purpose of the drawing, I've made them 80 by 20. The first step to get the mean proportion is to swing an arc. The arc is the radius of the side length. We then extend out our length of the rectangle to hit it. We then, to get the mean proportion, from here, we draw an arc the whole way over to the other end of the rectangle. Just tidy up, trim onto the way I don't need for the sake of the drawing. Now, to get the length of the mean proportion, we extend out this vertical side length to hit the arc. And this length is 40. The mean essentially is the average of both lines, the side length and the horizontal length of the rectangle. The mean allows us to create a square of equal area to a rectangle. And to do this, we get our circle again. We swing an arc the length of the mean proportion, which is 40, and we draw our square. Now, if this is right, the area should both be the same and the proportion. We're going to the area command, sorry. The area of the square is 1600, and by right, the rectangle should be 1600 also. And it is. So that's the mean proportion, as we have proved that the rectangle has the same area as the square. Today we're going to look at the angle subtended at the centre is twice the angle subtended at the circumference, standing on the same arc. Here we have our shape that touches our circumference from D to B to A, C, back to D. A is at the centre of the circle, and A, B, AC and AD are the same length as they're all radiuses. Because these are all the same length, D to A to B and A to C, we have now two isosceles triangles, which are AD and B and AD and C. We know that AD and AB are the same length, so that means angles 1 and angle 1 are equal. And also AC and AD are the same length, so we have angle 2 and angle 2, which are equal. We have that here, angle 1 is equal to angle 1, and angle 2 is equal to angle 2, because both are isosceles triangles. If we add angle 1 and angle 1 and angle 3, we get 180 degrees. And likewise, if we add angle 2 and angle 4, we have 180 degrees. You can see here we have a centre line running the whole way through the centre from D down to the very bottom of the circle. That means if we add angle 3 and angle 5, we get 180 degrees as well. And vice versa, if we add angle 4 and angle 6, we get 180 degrees. We know that the exterior angle on a triangle is the sum of twice the interior of an opposite angle. So angle 5 is twice the size of angle 1, and angle 6 is twice the size of angle 2. When we have that here, 2 times angle 1 is equal to angle 5, and 2 times angle 2 is equal to 6. Angle 1 at B is equal to angle 1 at D. So now that we've proved 2D, 2 at D is equal to A. So we've proven now that the angle subtended at the centre is twice the angle subtended at the circumference standing on the same arc. Today we're going to look at converting a pentagon to a rectangle of the same area. First of all, we have to convert the pentagon to a triangle. We do this by joining the corners, bottom 2 corners of the pentagon to the apex, and then bringing out lines parallel to hit the corner of the pentagon on each side. Then extend out the base of the pentagon either side, and then join. Where these intersect, you join to the apex. There you have your new triangle. We know the area of a triangle and area of a rectangle are linked. The area of a triangle is half the base by the perpendicular height, and the area of a rectangle is the length by the side. So we need a rectangle which is half the height of this triangle. You can see here I've put in a perpendicular bisector to get my length and height of the rectangle. From the corners of the triangle, I've erected 2 perpendicular lines which hit the perpendicular bisector. Now we can look at the pentagon and the rectangle and see if they have the same area, which they should. Join each of the 4 corners, and that's 3,804. Now, if my calculations are right, the pentagon should be the same. And it is 3,804. So that's how you convert a polygon, this pentagon, into a rectangle of equal area.